Good evening, ladies and gentlemen. We are Team Kinetically Integrated Computationally Created Axial Spooler System, otherwise known as Team KICKASS, with project members Jake Charlton, Michael Clark, Dimitri Ribich, and Michael Walmus.
Our task was simple: design a system that rolls up extruded HDPE from the Senior Design Project's extruder. We decided that our spooler should be user-controlled with adjustable speeds depending on how fast the extruder was working. Furthermore, this system had to be easily compatible with the actual spools used in the 3D printer. Finally, our project should be portable so that it can move around with the extruder as well as support itself some distance away from the extruder to allow for proper cooling.
To begin this project, we first needed to do some research on things that will be implemented in the final prototype. We researched and decided to use a system of sprockets rather than gears because they eliminate the necessity of tooth ratio calculations and they are easy to render and print. We also had to research the best type of motor to use to spin our spool. We chose to go with the small electrical motor because it would be very easy to control with the potentiometer and, because of its size, would nicely fit on our small spool system. More research was done on how to change from the small rotation on the motor to the large rotation on the spool axle. To distribute this torque, we chose to use a chain with our sprocket set because it is easily adjustable and eliminates slipping around the spool axle. Primarily, we considered having a system that would assist in guiding the HDPE onto the spool, but as more testing was done, we didn't see as much need for it and we decided to remove it in our final project.
Because of our design uses torque ratios from the motor to the spool axle, we needed to do some torque calculations so that we would find out just how much torque was required to spin a fully loaded spool, as well as what size sprockets we needed to create. We used simple torque equations like V equals R times omega, P equals gamma times omega, gamma equals R cross F, and save parameters to complete this task.
One essential component we needed to create was a component that would guarantee the spool to spin along the powered axle. We rendered a piece that fits snugly on the axle with 3 teeth that mesh inside the spool's notches. The spool, when connected to the spool locker, does not slip and spins at the exact rate of the axle.
We decided to make one of the spool support columns hinged on one side. This allows for easy removal and replacement of the spool once it has been fully reloaded. Also, the half circle on the hinged side reduces friction along the PVC axle. Finally, the support keeps the axle level to allow for equal distribution of the HDPE onto the spool. After building the frame for the axle, we found that we could incorporate the motor housing into the axle support beam. This helps because it lines up the motor and the axle sprocket so that it can be easily connected by a chain. Also, because the motor hole was made exactly the same size as the motor, it eliminates unnecessary motor movement and keeps it from sliding out of place.
We had testing goals for our final project detailing specific tasks that were critical for completion. Our spool had to be able to spin at a rate comparable to the rate at which the extruder is outputting freshly made HDPE. To solve this problem, we implemented a user-controlled potentiometer dial that can directly change the rotational speed. Also, we had to make sure our axle and locker were able to fit the 3D printer spool. Finally, our motor must be able to convert its high-speed rotation into low-speed torque. We did this by printing out sprockets of specific ratios.
This is our final project. Our challenges were overcome by implementing gear ratios and the use of chain and sprocket system. Our spool is fully supported and our axle slips easily along the rails. In trials, the HDPE easily wraps evenly along the spool and is easily controlled by a potentiometer.
From this project, we learned many things to apply to our senior design project in a few years. We especially noticed that things fail often and teams need to be able to roll with the punches. In the beginning, multiple brainstorming sessions were definitely beneficial to creating new ideas and having multiple options available. Finally, the last thing we learned, and the most important, if you plan ahead and always have a plan B, the project is more likely to get completed.